Righto guys, we're up to video number 9 in our series now. In this video we're going to look at rationalising the denominator. We spoke about irrational numbers way back in one of those early introductions. Well, what do we mean by rationalising the denominator? When we've got a fraction where our denominator is irrational, in other words our denominator has got a surd that we can't reduce down to a whole number or down to an exact number. Whenever we've got that situation, we like to rationalise the denominator. We like to go through a process where we can change the numerator and the denominator so that the denominator will be a rational number. We want to get that yucky surd thing out of the denominator. Let's look at a really easy example to start with, okay? So if I look at, say, 1 over the square root of 2. Okay, it's a fraction. It's got a numerator and a denominator. My denominator is irrational. I don't like that. Okay. Now, look, this is just the introductory video. I did a video with a heck of a lot more detail, and I'll put a link to that one in the description of this video. Okay, but I'm just going to talk about just some basic techniques. I'm not going to go deep into the theory. This is just a how-to. What do you do when? Okay, so when I've got a surd in the denominator like this, well then I just multiply above and below. So I multiply top and bottom by that surd. So I'm going to multiply by root 2 over root 2. That's not changing the value of anything because root 2 divided by root 2 is 1. So it's like that times 1 is still that. So that times root 2 over root 2 is still that, because root 2 over root 2 is 1. Okay? So now look at this. 1 times root 2 is root 2, and root 2 times root 2, well think about that. What's the square root of 2 times the square root of 2? Remember we did that video way back when we looked at the squares? I had a square whose area was 2, and I said, well, what would the side lengths be? And we said, well, they had to be the square root of 2. They had to be a number where you multiply by itself, you get 2. So that the square root of 2 times the square root of 2 was equal to 2. The square root of 2 times the square root of 2 is 2. When you multiply a surd by itself, it just gets rid of that square root sign. So root 2 times root 2 is 2. Well, look at that. Now I've got a fraction. I've got a fraction where my denominator is a rational number. I don't have a surd in my denominator anymore. Okay? It doesn't matter what my fraction looks like to start with. So let's look at a second example. Let's say I had 3 over 7 root 5. Okay? I don't care how messy or untidy or ugly my fraction looks. I'm going to multiply above and below by that square root part, okay, by the surd part. So I'm going to multiply by root 5 over root 5. Okay, on top I've got 3 times root 5 is 3 root 5. On the bottom I've got root 5 times, I've got 7 times root 5 times root 5. Remember, you multiply a surd by itself, it just gets rid of the square root sign. So that's 7 times 5. So that's just 3 root 5 over 35. Okay, that's it. Job done. Let's look at another example. So let's say I've got 2 root 3 over 5 root 2. Okay, I don't care that there's a surd in the numerator. I'm going to multiply above and below by the surd part of the denominator. That's all I do. Right? So I multiply by root 2 over root 2. Okay, to give myself a bit of room there. So on the top I've got, now remember when we're multiplying surds, the surd part gets multiplied together. So 2 gets multiplied by the 1 in front of there. So 2 times 1 is 2. Root 3 times root 2 is root 6. On the bottom, look at this, root 2 times root 2 Root 2 times root 2, remember you multiply a surd by itself, you get rid of the square root sign. So on the bottom I've got 5 times 2. That's going to be 2 root 6 over 10. I can simplify. Look at this. 2 over 10 is 1 over 5. So that's root 6 over 5. And that's job done. That's rationalising the denominator. Don't forget, I'm linking to one of the earlier videos I did on rationalising the denominator in the comments below. Make sure that you actually check out that video. Okay, because it goes through a little bit more detail behind the theory behind these, and it steps up to considerably more complicated examples. Okay, so if you follow this, which there's no reason why you wouldn't have, if you followed this, make sure you go and check out my other video on rationalising the denominator. Thanks very much. Next video is the last video, and all I'm doing in that is telling you about my other 2 videos. So that won't take long at all.